Welcome again to today's class. This day we want to solve some important questions on partial fractions. In the video before this, we had introduction to what partial fraction is all about. So we want to see how to solve all these questions. Now, when they ask you to resolve this to partial fraction, say, since these denominator are linear factors and they are non-repeated, that is, they are not the same, you say this means a over x plus b over x plus 1. So these are the partial fractions of this. Now the question now is, how do we get our a and b? We say there are three methods you can use to do that. 1, cover up method. 2, direct substitution. 3, comparing their coefficients. Now we can use any of this method. You can use one of the methods, you can apply 2 of the methods, you can apply 3 of the methods, depending on the nature or the type of question given to you. Now we now say, to solve this, we want to see how to get our a and b. So what we now do is that this is equal to this. That is what we are saying. We now say, to get a, take this x, equate it to 0. That is s is equal to 0. Then carry this x plus 1, use it to cover this up. You know, you have removed this and make it equal to 0. Use it to cover it up. That is how we got cover up method. So we are using cover up method to solve this. Make it equal to 0, then carry this put here. So once you put it here, the implication is that you are putting it into s plus 3 over, this is the numerator. Then what you use to cover it up is s plus 1. So this will cover this up for you to get a. Carry s equal to 0, put here. 0 plus 3, 3. 0 plus 1, that will be giving you 1. Then you say, therefore, a equal to 3. Then to get b, carry the denominator of b, equate it to 0. It implies s plus 1 equal to 0, s equal to minus 1. Now, use this x to cover this up because you have removed this to equate it to 0. Use this x to cover it up. So as you cover it up, you have s plus 3 all over x. You have covered it up with this your x. Minus 1, put it here. Minus 1 plus 3, 2. Minus 1 plus 3 all over minus 1. That will be giving me 2 over minus 1 equal to minus 2. Therefore, b equal to minus 2. So, I will now package. I say, therefore, s plus 3 all over s bracket s plus 1. The partial fraction of it, what is our a? 3. We say 3 all over x. What is our b? Minus 2. Minus 2 all over s plus 1. Now, that is right. Final answer to that. Then we go to question number 2. In question number 2, they say resolve 3 all over x plus 1 bracket s minus 1. This question can be put this way. 3 all over x squared minus 1. They are the same. So if you see this question this way, know that this is difference of 2 squared, s plus 1, s minus 1, difference of 2 squared. So they are the same thing. So once they give you this type of question, say that it will be, since these are non-repeated linear factors, s plus 1 is not the same with s minus 1. You say a all over s plus 1 plus b all over x minus 1. So you can use cover up method, direct substitution, comparing their coefficient. Let's use cover up method as well. We say to get a, what is at the denominator of a? S plus 1. You say make x plus 1 equal to 0. It implies that s equal to minus 1. So, as you carry this out to make it equal to 0, this s minus 1 will come and cover it up. So as you come and cover it up, you will be having 3 all over s minus 1. So this has covered it up. So you retain the numerator 3 all over s minus 1. This is the resultant of the cover up. So you carry minus 1 put here as value of s. 3 all over minus 1 minus 1 minus 2 equal to minus 2. Okay? Then you now say to get b, what is at the denominator of b? S minus 1. You say make s minus 1 equal to 0, it will be giving you s equal to 1. Then s plus 1 under a will come and cover this s minus 1 that have left the denominator. So this have left the denominator to be equated to 0. This will come and cover it up. You will be having the numerator 3 all over s plus 1. Then that will be giving you, as s equal to 1, put it here. 3 over 1 plus 1, 2, equal to b. This is equal to a. So we say final answer is 3 over s plus 1 bracket s minus 1 will be giving us, what is our a? Our a is minus 3 over 2 bracket s plus 1, because it has denominator s plus 1. Then plus, what is our b? We have 2. We have our b to be 3 over 2 bracket s minus 1. Answer. So that is your answer to the question. Now to solve question C, let's clean everything. To resolve question C to partial fraction, we say, okay, in which form this is a linear factor, while this is a repeated linear factor. So we say it will be in this form, a all over s plus 1 plus, this is a repeated linear factor, we say b all over s minus 2 plus c all over x minus 2 raised to power of 2. Now, I will apply direct substitution and comparing the coefficient method. How do I do it? I say, what is the LCM? LCM of everything here is s plus 1. This one is inside this, so this will cover it up. This one is inside this. Because s minus 2 is inside this, you say, I will use s minus 2 as the LCM of these two. So I will now divide. S plus 1 divide this, it will leave you with this. I will now say, that thing will leave you s minus 2 raised to power 2 times a to give me a bracket s minus 2 raised to power of 2. Then this divide this, it will give me b bracket s minus 2. If this divide this, it will be leaving you with s plus 1. So if you divide this, and another s minus 2 will remain. Then plus, what is this? This divide this will leave you with this. So that will be multiplying the c. So this dividing will leave you with this times this c. Now, I want to use direct substitution method first. I say, make x plus 1 equal to 0. As s plus 1 is equal to 0, it implies that s equal to minus 1. As I have minus 1, carry it and substitute inside everything. I will say, remember this, that all this numerator is equal to x minus 1. So I will carry s equal to minus 1 and put it on this numerator. This denominator is s plus 1, s minus 2 all square. That is the same question. Okay? So I will carry this, make equal to 0, have x equal to minus 1, and put it only at the numerator only. Put it at the numerator only. Minus 1 plus 1, 0. 0 times c, 0. 0 times b, 0. Minus 1 plus 1, 0. 0 times c, 0. Minus 1 minus 2 minus 3. Minus 3 square. That will be giving me a bracket minus 3 square equals to minus 1 minus 2 minus 3 square. Then minus 1 minus 1, that will be giving me minus 2. Then this will be giving me 9a equal to minus 2. Therefore, a equal to minus 2 over 9. Then I will say, how do I get my b and c as well? Now, to get my b and c as well, I will expand this. If I expand this, I will be having a bracket x square, x raised to power 2x square, 2 times x, 2x, 2x times minus 2, minus 4x, minus 2 squared plus 4. Then, plus b bracket, this times this, x square, this times this, minus 2x, this times this, plus x, this times this, minus 2. Then, plus cx plus c, because once they multiply it, they give you this. Now if I sort out minus 2x plus x, that will be giving us minus x. Minus x, then minus 2. Okay? Then I will now multiply it. I have ax squared minus 4ax plus 4a plus bx squared minus bx minus 2b plus cx plus c. Okay, remember all this you are seeing is equal to the numerator. Now, collecting like terms, we'll be having ax squared plus bx. Ax squared plus bx squared. Okay? That will be giving me that they have something in common, a plus b, x squared. They have x squared in common. Then this one, and this one are common. Then I will now say plus x bracket minus 4a minus b plus c. Then I will now compare this and this. I'll say plus 4a plus what? Plus 4a minus 2b plus c. Now, I will say I am equating u to s minus 1 because the numerator has s minus 1. Now, at this part, at this side, does it have power of 2? I'm comparing their coefficient. Here I have s squared. Does this side have s squared? No. It means that a plus b is equal to 0 because it does not have s squared. Yes. Then this have x. Does this have x? Yes. It has coefficient of 1. Means that everything here, that is minus 4a minus b plus c is equal to 1. Then this is equal to minus 1 because it doesn't have alphabet x. You say 4a minus 2b plus c equal to minus 1. Now, since our a is minus 2 over 9, it implies that here b will be equal to minus a. As this goes the other side, then therefore our b will be equal to 2 over minus bracket minus 2 over 9 equal to 2 over 9. So as your a is minus 2 over 9, your b will be 2 over 9. How do we get our c? we put it here. We say minus 4 bracket minus 2 over 9. That is our A. Minus, what is our B? 2 over 9 plus C equal to 1. Then what we now do is that, or let's put it in a better way. Make C subject of formula. C will be equal to 4A go to the other side will be giving you plus 4A. This go to the other side will be giving you plus B. 1 plus 4 bracket, what is our A? Minus 2 over 9. And what is our B? 2 over 9. So we'll solve it here. We'll continue from up here. C equal to 1 plus 4A plus B. So that is 1 plus 4 bracket minus 2 over 9 plus 2 over 9. That is equal to 1 minus 8 over 9 plus 2 over 9. So it will be giving you LCM 9. That is 9 minus 1 divided by 9 times is 9. 1 minus 8 plus 2. 9 plus 2, 11. 11 minus 8 will be giving me 3 over 9. That is 1 over 3. Therefore, C is equal to 1 over 3. So, we have gotten our A. We say A equal to minus 2 over 9. B equal to 2 over 9. C equal to 1 over 3. So what do? We package it now. We say that means what is our A? Minus 2 over 9 bracket S plus 1. Then plus what is our B? 2 over 9 bracket S minus 2. What is our C? Plus 1 over 3 bracket S minus 2 all square. Answer. Then we go to the last question on this. In the last question of this, you will notice that in the last question you notice that it's an improper fraction. If you expand it, this is equivalent to x raised power of 3 all over x squared minus 2x minus 3. Okay? Because x squared, x times is minus 3x plus x. That would be minus 2x minus. So, you notice that when you expand this, you have this. The highest power of the numerator is 3, while the highest power of the denominator is 2. Because of that, we must go to long division. Why? Because the numerator is not meant to. Because the numerator is not meant to be in higher power than the denominator. Because the numerator have higher power than the denominator, we go to long division method. We now put x squared minus 2x minus 3. Say it's dividing this. This divide this, we have x. X times is x cubed. X times is minus 2x squared. X times is minus 3x. You subtract. This subtraction sign goes for everything. This minus this, it has gone. Minus times is 2x squared. Minus times is plus 3x. So what you now do is I say x squared divide this plus 2. 2 times is 2x squared. 2 times is minus 4x. 2 times is plus minus 6. You put another minus. This and this will subtract. Minus times minus plus 3x plus 4x. We have 7x. Minus times this plus 6. So therefore we say that x cubed all over x squared minus 2x minus 3 will be giving us x plus 2, then plus 7x plus 6 all over What is the denominator? S plus 1, S minus 3. So this is what we are to rationalize,